Welcome to e-Padasala lecture series in computer science. In this module, we are going to discuss some more examples of decrease and conquer algorithms. Recollect that for the past two modules, we were talking about various problems that are coming under the category of decrease and design paradigm. So, in this module, we are going to discuss some more problems that are related to decrease and conquer. Especially these problems are coming under the category called decrease by variable factor algorithms. One of the primary algorithm coming under this category is called the Euclid algorithm, which is one of the oldest algorithm ever designed for finding the greatest common denominator of two integers. So, this module we are going to discuss about algorithms related to this. We are going to discuss the extension of binary search called interpolation search, where we are going to discuss about the principles of decrease and conquer. We also going to discuss lots of algorithm that are coming under the category called order statistics, where we are going to discuss algorithms like median kind of algorithms. So, we are going to discuss about the selection algorithm, also deterministic selection algorithm for finding the median. So, these are going to be the agenda of this particular module. As we said earlier, decrease and conquer design paradigm is one of the most important paradigm, where we are trying to establish the relation between problem of the given instance and its reduced instance of the same problem. And once this relationship is established, then we are going to exploit this relation in top down or bottom up manner to solve the problems. Okay. So, we have seen that lots of variations are there, like decrease by a constant, like a of n is equal to a power n is equal to a into a power n minus 1. Decrease by constant factor algorithms like binary search, where we have seen that the search space is reduced by what is a variable that is a constant factor. Then the last category is called decrease by variable factors, where the decreasing amount vary will depend on depends on the nature of the problems. So, in this module we are primarily going to take this decrease by variable factor only. We are going to take the problems like Euclid algorithm, where we are going to see how the GCD is obtained. Then interpolation search, this is an extension of search algorithm, where we are going to reduce the search space depending on the context of the given problem. Then selection algorithm, where we are going to discuss about how to find the kth smallest element in an array, and finally, we are going to discuss about what is a median algorithms. One of the primary algorithm which we will take for our consideration is Euclid. Euclid algorithm is for computing GCD, greatest common divisor algorithm. Historically, this is an ancient procedure designed by Euclid. Its period is approximately 300 year BC, before Christ. This algorithm aims at finding the largest integer that divides both A and B. So, for example, if we are given two numbers 24 and 36, you can say that GCD of 24 and 36 is 12. How this solution is obtained? The answer is very simple. We have to factor A and B into primes, and we have to find the common ones. So, that means you can see very well 24 can be factored as primes like 2 into 2 into 2 into 3, and 36 is factored as 2 into 2 into 3 into 3. So, now you can see very well the common is 2 to 3. So, that is going to be 12. So, factoring the numbers and finding the common number and its product will give you the answer for the problem of GCD. The same thing can be lucidly defined in the recursive form also. So, Euclid algorithm is based on the repeated application of equality. So, you can recursively say that GCD of m comma n is going to be GCD of n comma mod of m mod n. So, that means it is going to be the what is a resultant of the mod operations. So, now you can see very well the same problem I am taking GCD, the first number should be greater than second one. So, I am just swapping these two numbers. So, it becomes 36 by 24. So, recursively this is 24 comma 36 mod 24. So, 36 mod 24 is a remainder. So, that means it is going to be 12. Again you can see very well this is recursively 12 comma 24 mod 12. So, that means 24 mod 12 is going to be 0. So, that means you can see very well it becomes GCD of 12 comma 0. The second number is 0. So, that means you are going to return this as the result. So, you can see exactly the recursive form algorithm is as good as the original procedure. So, let us state the informal algorithms. So, read two numbers x and y. So, if y is 0, then return x as GCD, repeat while y is not 0, then divide x by y, set the remainder to r, change the value of x to y and change the value of y to y by r. This is going to be the non-recursive way of solving the problem. Informal recursive, we can use mod function. Suppose if y is going to be 0, then we are going to return x, otherwise we are going to call the algorithm in a recursive manner where we are going to apply this recursive formula. So, this is the formal algorithm. So, you can see exactly what is happening. Euclid x comma y, you can see very well if y is going to be 0, return x, otherwise it is going to be Euclid of y comma x mod y. So, this is going to be repeated till we are getting the answer. Okay. What is the complexity analysis? The complexity analysis of this algorithm is going to be like this. You can see exactly the size is measured by the second number, and it is a variable amount because it can be of any value, but we can say that at least by half the space is going to be reduced. So, that means you can see that it is going to be some sort of logarithmic 1. So, that means you can say that the complexity analysis of this algorithm is going to be order of log n. This is the complexity analysis of this particular problem. Another beautiful example is interpolation search, which is coming under the category of decrease and conquer. This is coming under the category called decrease by variable factor algorithms. You can just recollect how binary search was better than linear search by reducing the space search space by half. So, that means we are going to find the middle, and using the middle we are going to determine whether we are going to eliminate the first half of the list or the second half of the list. This idea we can go further by by changing the factor as a variable. Let us consider a dictionary. For example, let us say I am going to search for a name like Qadir. Are we going to apply binary search where the English letters from A to Z is going to be cut short by half as A plus Z divided by 2? No, it is not. We just use indexing mechanisms. So, Qadir starts with Q means we tend to go towards the near end of the dictionary to find entries. On the other hand, if we are trying to find let us say Ahalya, so we tend to go towards the beginning portion of the dictionary. This kind of logic is what we are calling as interpolation. So, that means which list should be discarded is based on the decision of where we are going to put a cut. So, that cut will vary depending on the situations. So, the idea is very simple, reduce the problem instance by a variable factor. For example, if this is a list and if I want to search for 8, binary search will put the cut in the middle. So, it will start from 14 and then it will search, but whereas in interpolation search we will try to go towards the end of the list, so that we can find the solutions faster. So, this is the idea. So, the logic is very simple, how to find the middle. This is not exact middle, this is the approximate middle. So, this is obtained by the formula k minus low divided by high minus low, where k is going to be the key and low is going to be the first element of the given array and high is going to be the last element of the given array. Once the approximate middle is obtained, now the problem is similar to your binary search only. Now, you compare your target with the approximate middle, and let us say if target is equal to your approximate middle, that means the problem is solved. So, that means we are going to return the central element of the list as the answer. Otherwise, we are going to recurse the first half, otherwise it is going to be the second half. This is the formal algorithm. You can see exactly what is happening. Algorithm, interpolation search, we are taking an array indexed by 0 to n minus 1 and we are reading the target key. The output is going to be k if it is present, otherwise it is going to be minus 1. So, like in the binary search algorithm, we are going to start with low equal to 0 and I equal to n minus 1. we are starting the loop while low is less than or equal to high. This is where it differs from your binary search, where the approximate middle is obtained using the formula, that is the floor of k minus low divided by high minus low, where k is nothing but your key and low and high are respective the first and last elements of the given array. Now, if k is equal to a of c, that means the element is present, we are going to return c, otherwise we are checking k with a of c. If k is less than a of c, that means we have to check the first half. So, that means it starts from index what you say low to c minus 1, otherwise it is going to be what you say c plus 1 equal to high. So, this is what the algorithm is. If it is not present, then we are going to return what you say minus 1. What is the complexity analysis of this algorithm? The complexity analysis of this algorithm is very simple. It uses the decrease and conquer. If the items are distributed uniformly, then you can say that the complexity analysis is order of log of n. If the items are not distributed uniformly, then what you say the complexity is going to be order of n. So, this is the algorithm for interpolation search. The next category of algorithm that comes under decrease and conquer category is called what you say order statistics. Order statistics means the statistics like maximum, minimum, median, mean, mode. These are all examples of what you say order statistics. Out of all the problem, we are interested in finding the ith order statistics. That means, given a list, can you say what is the ith smallest element of the set of n element? First order is minimum and nth order statistics is maximum. Recollect in earlier portions of the modules, we discussed about various algorithms for finding the maximum and minimum of the given array. In fact, as part of the divide and conquer strategy, we also applied the divide and conquer strategy for finding the minimax. Probably you can recollect that the list of elements are taken, then it is divided into two lists, then we are recursively finding the maximum and minimum of each and every sub list, and it is compared to send the maximum and minimum of the global list. So, now we are going to extend this idea for other things. So, we will take the primary problem of finding the median. So, median is the halfway point of the given set. Suppose if n is going to be odd, then the median is going to be n plus 1 by 2. Otherwise, we will have two center elements, that means a lower median is going to be I equal to n by 2 and the upper median is going to be n by 2 plus 1. By convention, always median refers to the lower median only. Therefore, we always return the lower median as the median of the given list. So, this is for the consistency purposes. How do we solve these problems? Conventionally, it is very simple. Conventionally, if I want to know the kth smallest element, means I will simply sort all the elements. Once I sort it, then automatically the first element of the sorted list is going to be the minimum, the last element of the list is going to be the maximum, and the middle element is the median, that is n by 2 if it is going to be what you say odd, like that I can find. If I want to find the kth smallest element, like the second smallest element or third smallest element, then these are respectively the second and third elements of the sorted list. So, in that particular manner I can easily find all the things. But what is the problem of this particular approach? This is a conventional approach. So, in this conventional approach, we want what you say all the item to be sorted. So, once we have this requirement, then I have to use quick sort or merge sort. So, that takes what you say the complexity of order of n log n. So, that means the complexity becomes large because sorting is a prerequisite for this particular approach, and after that I have to apply what is a search algorithm to find the kth smallest element. So, the idea is very simple. Is it possible to convert this algorithm into a linear order algorithm? That means, is it possible to solve this problem by means of order of n? So, this is the requirement, and we have ways to do that, and it is called selection algorithm. Selection algorithm means we will be given key like k, and the objective of this problem is to find the kth smallest element that is present in the given array. For example, if k is equal to 2 means, then our objective is to find the second smallest element that is present in the given array. So, the informal algorithm is going to be very simple. It is based on the design paradigm of decrease and conquer. We are going to apply the variable factor approach. So, that means we are going to divide the problems. So, we use a partition procedure like Hore or Lomuto to find the pivotal element q. Remember, we discussed these algorithms as part of quick sort, as part of divide and conquer design paradigms, where we discussed about Hore and Lomuto procedure to find the pivotal element q. So, now using this q, we are going to split the array into various sublists, where the sublist A of less is going to be all the elements that are going to be lesser than q, and A of equal is going to be the pivotal element q, and A of greater is going to be what you say all elements greater than q. So, now you can see exactly how this what you say decrease process is carried out. The decrease process is carried out by finding the pivotal element, and using this pivotal element, what we are trying to do is we are trying to reduce the problem instance by dividing the list into 3 lists, A less, A equal and A greater. So, once all the things are done, then we are going to count all the elements of A less, and it is going to be a variable called count, and if count is equal to k minus 1, where k is nothing but the kth smallest element that is being sought. If that is the case, then pivotal element is the answer for this particular what is a problem. It is going to be the kth smallest element. Otherwise, we are going to recurse array A less if count is going to be greater than k minus 1. Otherwise, we are going to recurse the array A greater. So, this is the informal algorithm of this. Now you can see an example of this. In the top you have a list. You can see that you have numbers, you are having partition. So, 4 is going to be the middle element. So, now I want to find what is a fourth smallest element. So, you can see that A less are the elements that are going to be lesser than the pivotal element. So, you can see the count of that list is going to be 3. So, you can check that k is equal to count. Therefore, you can see that the answer is going to be your pivotal element. So, this is the answer. Suppose if k is going to be 7, you can check that count is going to be 3. So, k is going to be greater than this. So, that means it has to be searched in the right part. So, right part is k minus count minus 1. So, that means 7 minus what you say 3 minus 1. So, that means it is going to be the third element of your A greater. A greater elements are 5, 6, 9, 7. You can see that third smallest element is going to be 7. So, that means again we have to apply the recursive procedure to what you say to the above list and the process is repeated. So, by that means by repeated recursing we can find the solution of the given smallest element problem. So, this is the formal algorithm. So, we have algorithm selection, k is the smallest item. So, find pivot q, we can make use of either the Hoare algorithm or Lomuto. So, now as we discussed earlier, we will get 3 lists A less, A equal and A greater. So, we find the count of A less, that is going to be a variable called count. If count is equal to k minus 1, then the pivotal element is going to be the answer. If count is going to be greater than k minus 1, then we are going to call the selection procedure in a recursive manner using A less and k, otherwise it is going to be A greater comma k minus count minus 1. So, this is the formal algorithm for this particular problem. What is the complexity analysis? The complexity analysis is going to be T of n is equal to T of n by 2 plus 1. So, that means at least half is guaranteed. So, even if that is the case, you can see that the complexity analysis is turning to be what is a T of n is going to be logarithm of n. We can extend this idea for median. So, this is a deterministic algorithm. So, the logic is very simple. Try to divide n elements into lots of list of n by 5. So, if there are excessive element less than 5, it goes as a separate group. Determine the median of every groups. Then once you have median, then you find the median of all the medians. Then once you have that, then you can partition what you say around that. So, again using the similar procedure by recursing this A less and A greater, we can find what you say the median. It is a deterministic median algorithm which guarantees what you say order of n. So, you can see that the complexity analysis is going to be the problem of finding median of median, partition and adding. So, you can see that we are cutting the list into lots of list of 5 element each. So, partition takes order of n and recursive calls. So, if you put together everything, you can see that it is going to be order of n. So, in summary, we can say that Euclid algorithm is very effective for finding GZT, and interpolation search is very effective, and the selection algorithms find the smallest element k in linear time. Deterministic median algorithm is quite possible, therefore, we can even find median in linear time. Thank you very much. We have completed the design paradigm of decrease and conquer. Next module we will meet again to discuss about transform and conquer, another interesting design paradigm. Thank you very much.